To perform scan data analysis, connect the scan tool to the vehicle's DCL connector. If the scan tool will not communicate with the vehicle, go to Mill and Scan Data Problems, and that menu is in the main menu. Do not guess at specifications. Always look up vehicle-specific specifications. Turn the key on, engine off, set your scan tool up to read data. And then we're going to compare each data bit to specifications and see which one is out of spec. Engine RPM should be 0. If it isn't, go to PCM testing. TPS should be within specs. If the TPS isn't within specs, test the TPS and its circuit. You can see where we're going here. We're just going to go down to the data bit looking for wrong data. Cold oxygen sensors should read close to reference voltage. If the oxygen sensors don't show the reference or close to the reference, test the sensors to see if they are shorted. If they are not shorted, go to PCM testing. Heated oxygen sensors will decrease voltage as they heat up with the ignition on. So if you're working with the ignition on, the heaters are working. Hot sensors won't read the 450 millivolts. Now for a complete analysis of long-term fuel trim, go to Fuel Injection First Test. Map sensor should be within spec. If the map isn't within spec, test the map and its circuit. Engine temperature sensor should match actual engine temperature. The ECT and the IAT, inlet air temperature, should match. They should be within 10 degrees of each other after the engine has been off for several hours. It's a good indication that they're working normally if they're close to each other after several hours of engine cool down. A more accurate test is to compare the ECT scan data to actual engine temperature. You can see that we're using our Raytech gun. Love those Raytech guns. Fast and accurate to measure actual engine temperature. Injector pulse width should be approximately 88 milliseconds on a cool engine. A cool engine we're calling 50 degrees Fahrenheit. If injector pulse width is not within this range, check for a reprogramming TSB, Technical Service Bulletin, and follow those instructions. Idle air control will show the amount of bypass air the PCM has set for the engine startup. IC counts vary with engine temperature. Now, example that we're showing you here, the 49.5 down in scan data, is on a cool engine, once again near 50 degrees Fahrenheit. System voltage should be 12.6, 12.8 volts, which shows a fully charged battery. If battery voltage is lower than fully charged, you have to find out why. It may be as simple as you've been testing with the ignition on for a long period of time, draining the battery. If you can't determine why, go to starting and charging system and see if there's a problem there. Now start the engine, let it fully warm up. With the engine running at idle, the data is going to change to reflect the measured information. So we have stopped the data at one point in time so that it can be discussed, and of course your data would be moving because you're looking at live data. Special note here, on some Chrysler modules, that system sense or that system voltage, that PID may be displayed as control module volts on some of the newer models. Just like key on engine off, we're going to go down through the data and compare it to specifications. Engine RPM should match actual engine speed. If not, go to ignition and fuel control testing. Compare the TPS to specifications. If the voltage is higher than specifications, it is possible that the throttle stop screw has been adjusted to compensate for a problem by a technician. If the TPS voltage is not normal, look at the IAC counts. This is a normal reading, this 34.8, on a vehicle that's in closed loop. If the counts are higher than normal, the PCM is commanding additional bypass air. Check the power steering pressure switch, the AC switch, and the park neutral switch to see if they're sending a command to the PCM to raise engine idle. Also check the throttle bore for restrictions. You can see we have a dirty throttle bore here. Now a dirty throttle bore, or the PS, the power steering pressure switch, AC switch, or the park neutral switch, can cause higher than normal IAC counts. If you see a dirty throttle bore, carbon buildup, that indicates that the manifold, the back of the intake valves, they are also carboned up. They're dirty. Only cleaning the throttle bore won't fix this problem. Carbon's also going to build up in the fuel rail and on the injectors. If the throttle has carbon build up, your decarbonization process must address the rest of the carbon buildup in the engine. Once you're sure that the throttle isn't dirty or the carbon has been removed because you did a cleaning service, continue on with the scan data diagnostics. If the counts are lower, if the IEC counts are lower than normal, the PCM is commanding less bypass air, check for vacuum leaks. Continue comparing the data to specifications. The oxygen sensors are going to be moving between 0.1 and 0.9 volts. If not, go to fuel pressure and volume testing. The MAP sensor should be within specifications. If the MAP sensor is higher than normal, don't forget, it may be good, so you want to check engine vacuum. Go to engine vacuum testing. If engine vacuum is normal, test the MAP sensors and its circuits. Now, a good helpful tip here is when we tell you to go test the MAP, TPS, ECT, one of these sensors, MAP testing, sensor testing on the MPC spec disc is what we use. It works out real well. If the MAP voltage is lower than normal, test the voltage reference, test it at the MAP sensor, and test for 5 volts, 4.9 to 5.1 volts. If reference voltage isn't within specifications, go to PCM testing. If reference voltage is within specifications, test the MAP sensor and its circuit. Engine coolant temperature should match actual engine temperature. Get your RATEC out again. If it doesn't, test the ECT and its circuits. The injector pulse width should match specifications. You can look up the specifications and you can see reading here in the white box there, lean command is under 1.2 milliseconds, a rich command is over 3.8, and we're at 3.3, so we're within specs there. The injector pulse width may not be within specifications if there's a fuel system problem. If the injector pulse width isn't correct, go to fuel pressure and volume testing. Inlet air temperature should match actual temperature. If it doesn't, test the IAT and its circuits. System voltage should match the specifications. If not, go to starting and charging systems. Remember, different PIDs are used for this system voltage, so it may not be in alphabetical order like you're used to. It may be called something else. Make sure you find it. When you find data that does not match specifications, you must determine why. Now, you will be returned to the test selection menu. Make a selection based on your test results.